power is the rate at which work is done. So we already talked about work a little bit. The unit for power is watts, and so 1 watt is equal to 1 joule over 1 second. Okay, so for example, a dim light bulb can use 40 watts while a bright light bulb can use up to 500 watts. Okay, because the brighter it is, the more work that's being done per second. So this is our equation, power equals work over time. Okay, there's some other forms of the power equation if you kind of substitute in. For instance, if you don't know work, you could plug in force times distance or displacement on top. If you look at that a different way, force times displacement over time is velocity. So these are just some different ways to find power, but it's all based on that work over time. So let's look at a sample problem. At what rate is a 60 kilogram boy using energy when he runs up a flight of stairs 10 meters high in 8 seconds? So we need to know what work is being done. So it's just his weight is what he's lifting. So we just multiply his mass times gravity. And so I get 588.6. And my distance is 10. So I just have to multiply those two together. And I'm going to get 5,886 joules, and that's my work. Okay, but I'm looking for power, so it said that took him 8 seconds, so I'm going to divide that by 8, and that gets me 735.8 watts. Okay, energy is also involved in this. It's the capacity of something to perform work, and my energy equation takes that power and multiplies it back by time. Remember, energy and work are very closely related. So if you look at this first equation, the power equals work over time, and you multiply it by time, that's going to cancel on the right. You have power times time equals work. Right above we have power times time equals energy. So remember, work and energy are very, very closely related. Okay, so the unit for energy is the joule. Power is measured in watts, as we talked about a few minutes ago, and then time is measured in seconds. At what rate is a 40 kilogram dog using his energy when he jumps up 2 meters in 2 seconds? Okay, that'd be a pretty slow jump for a dog, but we'll just go with it for our physics problem. So I need to label what all these things are. 40 kilograms, I know kilograms is mass, meters is my distance or my height, and seconds is my time. Okay, and I want to know what rate I'm using energy. That's another way to say power. So I'm looking for power. My equation for power is work over time, but I don't have W, so I'm going to have to work backwards. I know W is force times distance, and so I can put that in where work was. So I have distance, but I still don't have force. So if I work backwards again, I know that force is mass times acceleration. So I plug that in where the F was. I still have times D over time. And if I think about this, I have M, I have D, I have T, and acceleration in this case, it's pulling the dog down as gravity. So I have that. So I can use this equation to solve for power. So mass is 40 times acceleration is 9.8 times distance is 2, and my time is 2. Okay, so if I put all of that in my calculator and work it all out, that's going to be 392, and my unit for power is watts.